and welcome to your recorded lesson, the second one of this week with me, Miss Hyken. Today we're looking at compound interest, which is really exciting. Can you make sure you've got all of this equipment here and this date and title written down? You definitely, really importantly, need a calculator today. So can you make sure you've got that ready? Okay, so pausing it and getting that sorted now. Okay, fantastic. Absolutely raring to go today. All of our equipment laid out, our calculators ready to go. Very exciting. So just like normal, I have got your 5 a day. I want to see beautiful workings, pushing yourself to answer every question and getting on to that extension question down there. Okay, so press pause and make a start on that now. Okay, and 3, 2, 1, pens drop, green pens up, and ticking your answers. Okay, pausing it there if you need a little bit more time. Beautiful. So today we are looking at being able to calculate compound interest, okay? And we're bringing in loads of skills that we've been looking at over the last few recorded lessons to this lesson today. And again, this is a really good lesson for us to be looking at because it ties into lots of different subjects that you might want to do at university, but also is something that you can really imagine yourself using in everyday life, okay? So when you're saving money in that bank, using compound interest, when you're working out investments or buying something like a car, thinking about that depreciation and interest rate changes. So really, really interesting lesson today. I'm really, really excited to sort of get cracking with that today, and I'm sure you are too. So again, moving on to our really, really important retrieval practice today. And I want you to have a look at these 3 questions here. How familiar are you with your FDP, your fraction decimal percentage conversion? Okay, you need to be able to write numbers like this as a decimal. Now, if you don't know how to do that, that is absolutely fine, but go back and look at the FDP videos, the fraction decimal percentage videos from week 1, okay? The level 1 and 2 video lessons go into some great depth about that with Mr. Harmer. So if you don't know how to do this, we're not going to spend time doing it now. I need you to stop this video and watch the FDP videos from the first week, okay? Those are on YouTube, or go back and look at the first week on the Marine Academy Tap Into Map website at the first video with Mr. Harmer, okay? So fantastic. If you're staying with me, make sure you've got this copied down and you're ready to go. Beautiful. So question 1, write 4% as a decimal. Pause. And 3, 2, 1, pen drop, green pens up, and ticking. You should have 0.04. Fantastic. Well done. Question 2, write 20% as a decimal and pause. And 3, 2, 1, pen drop, green pen up. Fantastic. 0.2 should be your answer for that one. Okay, question 3 now. Write 7% as a decimal and pause. And 3, 2, 1, pen drop, green pen up, and ticking 0.07 as your answer there. Beautiful work today, guys. Fantastic. Remembering, if you need a little bit more time, go back and watch those videos with Mr. Harmer from week 1, really explaining this in detail. Question 4, write 1.5% as a decimal. Okay, remember what we're doing here. We're still dividing by 100. Thinking about that. Pausing it now. And 3, 2, 1, pen drop, green pen up, and 0.015. Okay, remember 1% as a decimal is 0.01. 2% as a decimal is 0.02. So 1.5% as a decimal would be 0.015. Okay, again, watching that previous video if you need some extra information on that. Question 5, write 4.5% as a decimal. Okay, and pause. And 3, 2, 1, pen drop, green pen up, and ticking 0.045. Really well done if you got that one there. Okay, good. So can you give yourself a retrieval practice score out of 5 for me then? Some really, really good work there, guys. Really showing me that you know this information. Fantastic. Okay, now in today's lesson, there is a lot of something that we call notation, okay? Now, notation just means how we write out mathematical things, okay, in formula, for example. So today, we're going to be starting off by looking at simple interest. Now, this is a recap, okay? I'm going to go through this quite quickly. If you think you need more time, Mr. Harmer has covered this in the week 1, level 2, lesson 2. So week 1, the first week, commencing the 15th of June, level 2, lesson 2. So if you're feeling stuck on this next stage, watch that video back and he does it in really, really good detail. Okay, I'm going to go through it quite quickly. This is a recap before we go on to compound interest. Okay, but anyway, going back to notation, for this lesson, we need to know some specific notation. Okay, so here underneath, you can see simple interest, I equals PRT. Okay, so to calculate I, we do P times R times T. Remembering, when letters are next to each other in maths, that means they are multiplied together, okay? Now, I stands for the interest we're calculating. P stands for the amount borrowed, or the principal. R stands for the interest rate. And T stands for the time, okay? Now, just like I've done here, this needs to be copied out really clearly before we move on. I would highlight it, okay? So pause it and do that now. Okay, good. And we're going to be applying that formula and that information, okay, to some real life questions that people use in everyday life to calculate different types of interest. Okay, so this formula down here is actually used in banks and to some extent by the government to work out interest rates and really important things for the economy like that. So it's really interesting that we're starting to look at that today and setting you up for those future steps that you might want to take. Okay. So the first question we're going to be looking at, calculate 3% simple interest on a 4-year loan of £450. Okay, so we're going to be starting off looking at this simple interest, which we've written our formula for there. Okay, question 2, calculate the total amount that will have to be repaid at the end of the loan. Okay, so I'm going to move over to the visualizer now and have a look at that question. Okay, so I've got my question here written out. Calculate the simple interest at 3% on a 4-year loan of £450. Now, we just need to understand a little bit of context before we move on, okay? So in this question, I've borrowed £455 from a bank, okay? So that's what a loan means. It's money that you borrow from the bank, okay? Now, this is simple interest. So at the start of that loan period, 4 years, the bank says to me, right, I'm going to find 3% of that £450, and that's what I'm going to charge you each year for 4 years. Okay, so that's what happens when you get a simple interest loan. Okay, you have to pay the bank some extra money for lending you the money in the first place. Okay, so to say thank you effectively for lending me the money, I have to pay them back a little bit. Okay, it's not really thank you though, you have to pay it. Okay, you have to pay that interest on your loan. Okay, so I've got my formula here. I equals PRT. Okay, that's what we've written down. I equals PRT. And I'm going to think about what each of these letters means. Now, I, that stands for my interest. That's what I'm calculating. So I'm just going to put a question mark there. Okay, P is the principal, okay, or the loan. We call that the principal, the loan, the amount that we're borrowing, okay? So that's £450. Now, R is the interest rate, okay? But we have to give this as a decimal, okay? That R needs to be given as a decimal. So what's 3% as a decimal? We've just been doing that in our retrieval practice. 3% as a decimal. Good. 0.03. And the T stands for my time, which is 4 years. Okay. So I worked out what each of my components means, and then I can generate my answer. Okay, I can put that into the equation and work out the simple interest. So my interest, my simple interest, is equal to the principal, 450, times by the interest rate, 0.03, times by the time, which is 4. Okay, and I'm going to write that out underneath so it's bigger and it's clearer as to what we're doing. Okay, so I, just copying it out so it's a bit bigger, equals 450, that's the principal, times 0.03 times 4. Okay, the principal times the interest rate times the years, okay, or the time. Okay, pause it and copy that out now. Good, okay, so we're going to type that into our calculator, and it's really important that we've got our calculators ready. Pause it if you need to get yours now. Good, so we've got 450 times 0.03 times 4. £54, okay? So the extra interest that I need to pay is £54, okay? So I have to pay my £450 back, but I also have to pay back £54. That's the interest, okay, or the amount that the bank charges me for taking out the loan from them, okay? So when you borrow money, you get charged an extra amount, okay, because you've borrowed that money. That's your interest. So this is the interest that we have to pay back, okay? So pause it and copy that out. Okay, lovely. So the next part of the question then, I need to calculate the total amount that will have to be repaid at the end of the loan. Okay, so just like I was talking about before, you pay that back the amount that you borrowed and the interest. The amount that you borrowed, the principal, and the interest. So we have to pay back the £450 and we have to pay back the £54 of interest that we just calculated. Okay, we've got to pay back both of those. And again, you should be able to work that out in your head, but I'm going to type into my calculator. 450 plus 54 gives me £504, okay, total that I have to pay back. I pay back the amount that I borrowed and the interest, okay? So copy that down, pausing it now. Good, so now it's your turn, okay? Calculate 5% simple interest on a 2-year loan of £600. That's the first bit that we did using this equation, okay? So exactly the same steps. I equals PRT. Then part 2, calculate the total amount that will have to be repaid at the end of the loan. So add the interest to your principal or start amount, okay? If you need to do this in more detail, watch the video that I mentioned earlier, okay? The week 1, level 2, lesson 2 video, okay? So the level 2 second video from the week commencing 15th of June, okay? If you need to see this in more detail. Okay, so off you go, pausing it now. Good, and 3, 2, 1, pen drop, green pen up and ticking your answer, okay? £60 and £660 then total, okay? Fantastic, guys, really good work there, well done. Okay, wonderful. So we now need to apply those skills to some practice questions to make sure that you've really got that with your independent practice, okay? So I've got 3 questions exactly the same as the ones that we've just done for you to have a go at now, looking at your notes and laying it out just as I did, okay, to make that really clear. Okay, so pausing it now and off you go. And 3, 2, 1, pen drop, green pens up, ticking your answers there, okay? Pausing it to do so if you need some more time. Good, and really, really well done there, guys. That's going to really set us up for the rest of this lesson. And that's some really important skills that we've learnt there that we can apply to everyday life even when we leave schools, okay? But also, it's a really good example of how maths can be used in different degrees or at university, okay? So really interesting stuff there. Well done. Okay, so we're looking at compound interest now, and this is a little bit different to simple interest, okay? So I just want all pens down, just listening whilst I explain the context for now, okay? So with simple interest, the bank at the start says, right, I'm lending you this amount, okay? I'm going to calculate 3% of that, times it by the number of years, and that's how much you're going to pay me back. So if you have £100 that you're borrowing, okay, they're charging you 2%, okay, that would be £2, and they'll say, right, £2 over 3 years, you need to pay me back £6, okay? They work it out at the start. They take the percentage from the start value. Now, compound interest, on the other hand, is a little bit different, okay? So what you have to do is you work out the percentage of the amount at the end of each year, okay? So it's a little bit more confusing. Okay, so with compound interest, you have an interest rate, okay? So you pay back each year a fixed amount, okay? So in the first year, if you are borrowing £100, okay, and your interest rate is 2%, you'd pay back £2 that year. Okay, so your total loan then is £102. What then happens is the bank then calculates the interest on that new amount, so you'd be paying a little bit more each year. Okay, and that's what actually happens in the real world. So it's a little bit different because the interest doesn't stay the same each year. So we have to use a new formula. Okay, so with compound interest, the future value is equal to the present value times 1 plus r to the power of n, okay? Okay, and this looks a little bit confusing, okay? But we're going to talk through it, and when we do some examples, it's going to become really clear. It just looks a little bit confusing now, okay? So, FV equals PV times 1 plus r to the power of n, okay? And FV is your future value, PV is your present value, R is the annual interest rate, and N is the number of periods. And I promise you, when we go to the visualizer, it will become a bit clearer. But for now, can you make sure that that is really clearly copied out, please, in your books there? So off you go. Okay, so this should be beautifully copied out now then, ready for us to go. Pausing it if you need a bit of extra time to do so. Okay, so we're going to be looking at questions like these ones here. Jess invests £3,000 in the bank for 5 years. The compound interest on the saving is 2%. How much will she have in the bank at the end of 5 years? Now, we are looking now at the opposite, a different type of question, where you are saving money with a bank. Okay, so we're no longer thinking about loans, we're thinking about saving money. Okay, so Jess has £3,000, okay, and what she's going to do is she's going to put that in the bank. Okay, she's going to say, I'm going to save my money with you. Now the bank, to reward Jess for saving money, okay, they're encouraging her to save money. They say, right, well, we'll give you back your £3,000 when you want to take it out, but we'll also pay you a little bit extra each year to say thank you, or to say well done for saving that money, Jess. Okay, so she puts £3,000 in the bank, and the bank gives her a little bit of extra money each year. Now we're thinking about compound interest, okay? So in the first year, she saves £3,000. They find 2% of that and add it on. That's how much she has at the end of the first year. They then take 2% of that new total, okay, and that's how much she earns extra in the second year. Now that's a little bit more because she had more in the bank at the end of year 1, okay? So that's what happens with compound interest, okay? You get a little bit more interest each time because it's calculated from your new amount, okay? Now I'm going to show you how we use this formula to work it out on the visualizer. Again, it's going to become a lot clearer when we're actually modelling it and doing the maths, okay? So just making sure that you've got this copied out and you're ready to go on the visualizer. Okay, so I've got my question here. Jess invests £3,000 for 5 years at a compound interest rate of 2%, okay? Right, now what we're doing is working out how much she will have in 5 years' time. We are calculating the future value of that money. We're working out how much she would have earned on that £3,000. So how much it will be worth £5 in the future. Okay? And just like before, our first step is going to be to write out everything we know. Okay? So our future value is what we are calculating. We're working out how much we're going to have in 5 years, how much that £3,000 is going to be worth in 5 years. We know the present value, the amount of money she has now is £3,000. We know her interest rate is 2%, but again, we don't write it as a percentage, we write it as a decimal. So what's 2% as a decimal? Good, 0.02. And then the N is how many years, or the time, and it's 5 years. Okay, so we filled in all of our information and we're ready to go. So pause it now and make sure you've got that copied out. Okay, so we can start to fill in our formula then, okay? So we know that the future value, which is what we're calculating, is equal to the present value, 3,000, times 1 plus r, so 1 plus 0.02 to the power of n, so to the power of 5. Okay? And in order to type that in, I'm just going to work out what this bracket part means. So my future value is equal to 3,000 times, what's 1 plus 0.02? Good. 1.02 to the power of 5. That's exactly the same thing. I've just worked out what's inside my bracket and then raised it to the power of 5, just like here. Okay, it's exactly the same thing. And then I'm going to type that into my calculator. So I've got 3,000 times 1.02 to the power of 5. So 3,000 times 1.02 to the power of 5 equals 3312.24241. What do we round to when we're dealing with money? Good, 2 decimal places. So I get £3,312.24. So after 5 years, she won't have £3,000, she'll have £3,312.24, okay? She's got extra to reward her for having saved with the bank. Okay, quite a lot to think about there. Can you pause it? Make sure you've copied that out, okay? And if you need to watch that again, pausing it as you go, feel free to do so before you try for yourself. Okay, so if you need to, pausing it now. Good, so if you're with me now, that must mean that you're feeling confident and you're ready to go. Fantastic. Remembering you can always rewind and watch that modelled example again if you need to. So your turn now. Ed invests £1,500 in the bank for 3 years. The compound interest on the saving is 4%. How much will he have in the bank at the end of 3 years? And remember, use this formula to help you do it, laying it out exactly like I just did. Okay, so pausing it now to have a go. Okay, and 3, 2, 1, pen drop, green pens up, and ticking your answer. He will have £1,687.30. Okay, if you need to go back and watch my modelled example again, do it now before we start practicing some more. Okay. Lovely. For those of you ready then, we're carrying on with some questions. I've got some applied practice for you to have a go at. Okay, 3 questions, exactly the same process, substituting into that formula. And I want you to really have a go at that extension as well, pushing yourself, okay? substituting in numbers, seeing how long it will take her. Okay, that's how we're going to do it. Try a few different numbers, see when you get above 22,000. Okay, so pausing it now and off you go. Okay, and 3, 2, 1, pen drop, green pens up, and ticking your answers there for me. Okay, pausing it to do so now. Okay, fantastic. An absolutely brilliant lesson today, guys. Again, some really difficult skills, and we've just shown really great resilience. We've worked really hard through that. We've looked back at the level 2 video if we've needed to. We've looked back at the modelling examples and paused it if we needed to. Some really good independent work there, setting ourselves up to be independent learners at university. Well done. Okay, underneath this lesson, as normal, is your Google form. The Google form questions, these ones here. Can you take the time to answer them now? And also on Friday, can you make sure that you are completing your quiz? Okay, on your Google form on Friday, it will link you to a quiz on Sparks. I need you to answer those questions on Sparks so I can see how you're doing so that we can make your live lesson related to going back over material that you've struggled with. Okay, so on Friday, there will be a Sparks code. Okay, and I need you to answer the questions on that Sparks sort of lesson / quiz so that I know what you know. Okay, fantastic. That's bye from me today. See you later. Have a lovely weekend. Bye-bye.